Good afternoon, student. In this lecture, we are going to study galvanic cell, or it is also called as voltaic cell. We know that in galvanic cell, chemical energy is converted into electrical energy. In galvanic cell, spontaneous reaction occurs which produces electricity. In galvanic cell, look at here representation of galvanic cell. In this cell, anode is negative, cathode is positive, and it consists of, galvanic cell consists of two half cell. One half cell consists of zinc anode, which is deep in solution of 1 molar zinc sulfate solution, which contain zinc plus 2 ions of 1 molar solution. And second half cell consists of copper electrode, which act as a cathode, which is positive electrode. Copper electrode is deep in 1 molar solution of copper sulfate, which containing copper plus 2 ions. In this way, galvanic cell is made up. That is, galvanic cell is made up of two half cell, and these two electrodes, that is zinc anode and copper cathode, are connected by electrically conducting wire. Then two solutions are connected by this U-shaped tube called as salt bridge. What is meant by salt bridge? What are the functions of salt bridge? We will discuss in detail in next point. First of all, this is the outer line of galvanic cell. This is one example of galvanic cell, that is Daniell cell. In galvanic cell, potential of cathode is always greater than potential of anode. Galvanic cell are used to generation of electricity. Therefore, galvanic cell are very useful in our day-to-day life. We also use galvanic cell, that means lead storage battery. Our inverter is also one example of galvanic cell. This is the about galvanic cell. The next, what is meant by salt bridge? In this diagram, salt bridge is U-shaped glass tube. It consists of saturated solution of either potassium chloride or ammonium nitrate plus 5% agar solution. Ions in salt bridge, that means it consists of KCl, that means it contains K plus and Cl minus ion. These ions cannot undergo either oxidation or reduction, cannot participate in electrochemical reaction. Then what are the functions of salt bridge? Functions. First function, from diagram it clearly indicates that it maintain electrical contact between two solution and hence thereby complete circuit. This is the main function of salt bridge. It maintain electrical contact between two solution and thereby complete circuit. Second function of salt bridge is it prevent mixing of two solution, and third function is it maintain electrical neutrality between two half cells by flow of ions. For example, if At anode side, their positive charges are greater than negative charges, then that positive charges are neutralized by flow of Cl- ions in a salt bridge at zinc anode side. In this way, electrical neutrality is maintained between two solutions by using salt bridge. These are the three important functions of salt bridge. Cell notations having some rules. There are IUPAC convention during writing cell notation. First is inert electrode or metal electrode are placed at the end of cell formula. For example, from this diagram, I write here cell notation. Here, zinc electrode act as an anode, therefore it is placed at the extreme left hand side of the cell notation. Zinc solid, single vertical line, zinc plus 2 ion having 1 molar concentration, double vertical line, copper plus 2 having 1 molar concentration, single vertical line, copper solid. For example, this is the one type of cell notation. In cell notation, first rule is metal electrode or inert electrode. Here, zinc and copper electrode or metal electrode are placed at the end of cell formula, extreme end of the cell formula. Therefore, zinc electrode and copper electrode are placed at the end of cell formula. This is first rule. Second, aqueous solutions of ions. Aqueous solutions of ions are placed middle of the cell formula. Here, zinc electrode is deep in 1 molar zinc sulfate solution. Therefore, these two aqueous solutions, zinc plus 2 ion and copper plus 2 ions, are placed at the middle of cell formula. Then third rule is left hand electrode is always anode, right hand electrode is always cathode. We know that at anode oxidation takes place, at cathode reduction takes place. Therefore, in this cell notation, left hand electrode, that is zinc electrode, act as an anode and copper electrode act as a cathode. Then what is meant by this single vertical line? What is meant by this double vertical line? Single vertical line indicate direct contact between solid electrode and its aqueous solution. Here, this zinc solid electrode is deep in solution of its own ion having 1 molar concentration. Therefore, this single vertical line indicate direct contact between this zinc electrode and its solution, and double vertical line indicate these two solutions are connected by salt bridge. Then next rule is, if solutions of two valency state is available, for example Fe2 plus ion and Fe3 plus ion, aqueous solutions of these both ions is available, then this such a type of solutions in a two valency are indicated by or separated by comma and then electrode, that is platinum electrode. Then next rule is, if electrode act as a cathode, then sequence of writing is aqueous first and then solid electrode. For example, copper plus 2 ions having 1 molar concentration, single vertical line, copper solid. In this electrode, aqueous solution first and then solid electrode, therefore it acts as a cathode. If this electrode acts as anode, then this sequence will be reversed. That means copper solid first and then copper plus 2 aqueous, then this electrode acts as a anode. These are the some rules for writing cell notation. For example, cell composed of magnesium anode and copper cathode. Cell composed of magnesium anode and copper cathode. Two electrodes are represented as Mg plus 2 having 1 molar concentration, single vertical line, magnesium solid, and another electrode is copper electrode. It consists of copper plus 2 ion solution and copper solid electrode. By using these two electrode, we have to write cell notation. We know that in cell notation, metal electrode or inert electrode are placed at the end of cell formula. Solutions are aqueous solutions of ions are placed at the middle of cell formula. Then at left hand side anode is placed and right hand side cathode is placed. In these two electrode, magnesium acts as a anode and copper acts as a cathode. Therefore, magnesium electrode is written at left hand side. At left hand side it is anode and this one is cathode. Then one thing is, remember to write anode, sequence of electrode is solid first and then aqueous if electrode act as a anode, and here aqueous first and solid after. Therefore, this electrode must be reverse. Magnesium solid, single vertical line, Mg plus 2, 1 molar concentration, and we know that two half cells or two solutions are connected by salt bridge. It is indicated by double vertical line, and another is cathode. Right hand electrode is cathode. In cathode, sequence of writing electrode is aqueous first, therefore it is as it is single vertical line, copper solid. This is the cell notation of this electrode. By using convention, these two solid electrode are placed at the end of cell formula. Two solutions are placed at the middle of cell formula. Anode at left hand side and cathode at right hand side. Double vertical line indicate these two solutions are connected by salt bridge. Then next example, second example, if cell composed of hydrogen gas electrode as a anode and silver electrode as a cathode. Hydrogen gas electrode is written as hydrogen gas is adsorb on platinum, and that platinum electrode is deep in solution containing H plus ions, and it acts as a anode, and silver electrode it acts as a cathode. From these two half cell, we have to write cell notation. We know that anode is placed at the left hand side. Therefore, hydrogen gas electrode is placed at the left hand side, but its sequence is, it is act as an anode. Here aqueous first and then inert electrode. And we know that first rule, metal electrode or inert electrode. Here platinum electrode is inert electrode which is placed at the end of cell formula. therefore this sequence must be reversed. Platinum, single vertical line, hydrogen gas, H plus ion solution having 1 molar concentration, then double vertical line, this is 1/2 cell, that is anode, then another half cell is silver electrode, it acts as a cathode, therefore sequence is as it is, aqueous first and then solid. This is the cell notation for these two half cell. Here inert electrode platinum and silver solid electrode is placed at the end, and two solutions are connected by salt bridge which are placed in middle of cell formula. These are the some rules to write cell notation. Then next point is writing of cell reaction. Writing of cell reaction. There are also some rules to write cell reaction. First one is, we know that left hand electrode is anode. At anode, oxidation reaction takes place. Right hand electrode is cathode. At cathode, reduction half reaction takes place. But by addition of oxidation half reaction and reduction half reaction, we get redox reaction. In all electrochemical cells, reaction occurs that are redox reaction. What is meant by redox reaction? If oxidation reaction and reduction reaction takes place simultaneously, then that reaction is redox reaction. Therefore, by adding oxidation half reaction and reduction half reaction, we get redox reaction. One important thing is that electron in both reactions, that is oxidation half reaction and reduction half reaction, must be same and they are cancelled with each other. For this purpose, we have to multiply one or both equation by suitable numerical factor. For example, zinc electrode, zinc solid, zinc plus 2, 1 molar, double vertical line, copper plus 2, 1 molar and copper solid. For this cell, we have to write cell reaction. Then first, left hand electrode, anode, that is zinc act as a anode, right hand electrode, copper, which act as a cathode. We know that at anode oxidation takes place, therefore in this cell zinc metal undergoes oxidation by loss of 2 electron, because here zinc plus 2 ions. First write oxidation half reaction. Zinc undergoes oxidation by loss of 2 electron. Then these 2 electrons are transferred from anode to cathode. Here cathode act as a copper electrode. These copper plus 2 ions accept this 2 electron to form copper metal. This is reduction half reaction, and by addition of these 2 reaction, while adding these 2 equation, it is confirmed that electrons involved in both reaction will be same. If it is not same, then it is necessary to multiply one or both equation by multiplied by suitable numerical factor. Here 2 electrons are same, therefore electron lost by zinc metal which are accepted by copper plus 2 ions, therefore these 2 electrons get cancelled and remaining is zinc plus copper plus 2. It gives zinc plus 2 plus copper. This is the cell reaction. It is redox reaction, that is oxidation and reduction takes place simultaneously. Then second example, consider cell lead plus 2 ions, double vertical line, and silver. For this cell we have to write cell reaction. We know that left hand electrode is anode, therefore lead electrode act as a anode and silver electrode act as a cathode. We know that at anode oxidation takes place, therefore lead undergoes oxidation by loss of 2 electrons. Plus 2 electron. This is oxidation half reaction. Then electron lost by lead which are accepted by silver plus. Silver plus required only 1 electron to neutralize. This is a reduction half reaction. But while adding, it must be confirmed that electrons in both reactions are different. Therefore here we have to multiplied by suitable numerical factor to reduction half reaction so as to both electrons are same. If we multiplied by 2 to reduction half reaction, then 2 multiplied by 1 electron, 2 electron, 2 electron will be same and this electron get cancelled. Then if we multiplied 2 multiplied by 2 to reduction half reaction, then these 2 electron get cancelled. Remaining is lead solid twice silver plus. It gives lead plus 2 ions plus twice silver. This is cell reaction. In this example, we have to only multiplied by reduction half reaction. In third example, chromium electrode, chromium plus 3 ion in aqueous state, double vertical line, and nickel electrode, nickel plus 2, nickel solid. For this galvanic cell we have to write cell reaction. Chromium electrode act as anode and nickel electrode act as a cathode. At anode, chromium undergoes oxidation by loss of 3 electrons. Chromium plus 3 plus 3 electron. This is oxidation half reaction. This electron lost by chromium atom or chromium metal which are accepted by nickel plus 2 ions. Nickel plus 2 ions accept only 2 electrons and get neutralized. This is a reduction half reaction. Now these two equations indicate that Here 3 electrons are lost, and in reduction half reaction 2 electrons are accepted. How will you equalize these electrons? Here we have to multiply it by both equation by suitable numerical factor. If we multiplied by oxidation half reaction by 2, then 3 into 2, 6 electron, and reduction half reaction by 3 into 2, 6 electron. Therefore, we have to multiply both equation by suitable numerical factor. Then by multiplying 2 chromium, it gives 2 chromium plus 3 plus 6 electron. This is oxidation half reaction. Then for reduction half reaction, multiplied by 3 nickel plus 2 aqueous plus 6 electron, it gives 3 nickel. Then in both equation, number of electrons are same. Therefore this electron get cancelled and remaining is 2 chromium plus 3 nickel plus 2 aqueous to form 2 chromium plus 3 aqueous plus 3 nickel solid. This is your cell reaction. In this way, we can write any cell reaction by using these rules. In next lecture, we will see electrode potential and cell potential.